Aloha. I wanted to do this brief screencast because I came across a book, actually, it was recommended by Henry Casanova. You should always take Henry Casanova's advice whenever he suggests something. Just go ahead and do it. That's how I feel. Anyway, Henry suggested I look at this book, and I think it's such an interesting book that I wanted to give you a brief screencast to talk about it and hopefully entice many of you to check it out and incorporate it into your undergraduate degree experience. First thing I want to note is this book, in my opinion, is really good at helping you assess whether or not you've achieved competency, and in fact, help you get competent in computer science. But that competency is only one piece of the puzzle. You also want to do innovative things during your degree experience, and you also want to gain some experience in real world settings. So we have the RADGRAD system, which helps you figure out how to do that, and I'm giving a little plug for that here. But in this talk, I want to talk more specifically about competency. And what does that actually mean? And it turns out in ICS, competency is defined by taking a set of courses and getting a passing grade. And that's pretty similar to the way any academic program works, but it's not the way competency is perceived in the real world, and that's what I want to talk about. When we talk about competency, of course, that depends upon the kind of job you want. My personal criteria for a good job is that it involves doing innovative development, that involves writing software or building software, and that it pays well. So if you want more than two out of those three things, then the rest of this talk is for you. If you only want two, if you're satisfied not being paid to do work, then of course it's easy to find things that are innovative and involve coding. But the trick is to get all three of these things. So in this real world, what I've come across that I think does a fantastic job of helping you make sure you're competent is the following book, Cracking the Coding Interview. And I think a lot of you have seen this book, you have a friend who has it, or you've heard about it, and I want to spend a little time kind of showing you what's inside and why I think it's such an incredible resource. First of all, it's written by someone who really knows the situation with getting high-tech jobs. She's interviewed at a bunch of different great high-tech companies. She did technical hiring at several companies. And almost beyond that, it's not, at this point, the sixth edition, it's not just her. It's hundreds of people who've contributed questions and experiences to her. So I think actually this is the most comprehensive evidence-based perspective on how industry currently defines competency. It's a pretty cool thing. It's a really, I think, amazing resource for those of you who are starting out. I wish I'd had something like this when I was an undergrad. So, why do you care how industry defines competency? Well, you might want a good job in industry after you graduate. Probably all of you feel that way, but also because competent means you can do more stuff. It's fun to be competent. So, there's a self-interest there beyond just interviewing. There's some myths, that only a few companies test coding skills. Actually, all the good ones do. Really, I think there's there are some that don't, but it's you're really limiting yourself if you avoid any company that doesn't have coding testing. Whiteboard coding doesn't assess useful skills. If done improperly, if done in an improper way by incompetent people, yes, whiteboard coding is going to be bad. But in fact, this book is also used by organizations who need to train their interviewers. So in that sense, I think increasingly the sophistication of the whiteboard problems is growing, and it's actually becoming a more useful evaluation process. The other thing is you think, oh, I'll wait until I'm about to graduate. And as you'll see in a second, no, you have to start thinking about this way earlier. And that's one of the reasons why I'm putting out this screencast, is to give all of you a heads up that you need to start thinking about this now. Finally, cracking the coding interview has a lot more in it than just coding questions. And that's another big thing I'm hoping to get across to you, is that you can learn a lot more than just seeing, some kind of algorithm search questions. So here's the contents. It starts off with a chapter that I found really fascinating, where she goes through the interview process at a variety of high-tech firms and talks about the similarities and differences between them. And I certainly never knew what the difference was between a Microsoft interview and a Google interview, but now I do, because I've read the book. She also talks about how to prepare for the interview, and the preparation is a year or more long. Okay, so and I really like that. It's not something that you can just in a few weeks get ready. You need to start a year or more in advance. Finally, it has one of the best descriptions of how you go about solving technical problems that I've ever read. I mean, it's just really fantastic. It's worth the price of the book alone, to see how she describes how you go about thinking about problems and solving them. So on the right-hand side, you could see this long list of things. These are the basic topic areas that you need to be comfortable with at some level in order to do well in the interview. You'll do better at certain things than other things. As a new graduate from an undergraduate degree program, you're not going to have super sophisticated ideas about system design, for example, but you should have some ability to talk about that. And not be just completely confused and out to lunch when you do so. So those are the topic areas. And then she talks about how competency is assessed, and it's a combination of analytical skills, coding skills, technical knowledge, experience, and culture fit. These are good things to kind of keep in mind as you get closer to the interview. So a lot of people think, oh my God, these whiteboard interviews, they're terrible. But right in the middle of the page, I think, is a really compelling reason to think about them as being important and something you're probably going to have to deal with. And that's that for the company, false negatives are acceptable, but false positives are not. In other words, they're going to interview a lot of people, and if they screen some good people out because they happen to do poorly at the whiteboard interview, that's okay. What they don't want to do is hire somebody who's actually not technically competent. And so for that reason, even though whiteboard, coding is got problems, it is an artificial environment. It does serve the purpose of filtering out false positives and while still leading to a certain number of false negatives. Here's the preparation map. I think this is just really fantastic. And I'm just going to talk about I'll show you. I mean, the second slide shows the second half of it, right? So it's 2 pages long. There's a lot of details in this thing. But I just want to focus on the fact that a year or more before you intend to graduate, you should start thinking about this process. And a year or more before, you should be building projects outside of school and work. That's really important. Open source projects or hackathons or whatever. You should start building your portfolio at least a year before you graduate. You should learn multiple programming languages. That's hopefully something that will happen as a result of doing your degree program. And then it says build website portfolio showcasing your experience. Now, that's a requirement in ICS 314. So you're going to build one, but I want to emphasize here that you need to keep it up to date. You need to be thoughtful about it and make it represent what you've done, and then use it as a way to figure out what you need to do. What are the weaknesses in your background that are exposed by your portfolio, and then go ahead and fix them. And then it goes on and on. I won't go through this in detail, but I'm just going to show you. There's a lot of awesome recommendations here. So it turns out that, as it says, you're usually only expected to know the basics. Here's a list of the absolute must-have knowledge, and if you look at the table there, there's nothing there that's super complicated, right? So there's no red black stuff, and so what she recommends is to practice implementing the data structures and algorithms on paper and then on a computer. Okay? And then at the bottom, she has a little sidebar that says, did you miss that paragraph? It's important. Practice implementing the data structures and algorithms on paper, then on the computer. Okay? So do that, right? If you don't believe me, believe her. Okay? She's got a lot of experience with this. So just to give you a taste for um, how the book looks, here's the very first problem: implement an algorithm to determine if a string has all unique characters. What if you cannot use additional data structures? Great question. You could just pause right now and spend a few minutes if you want trying to solve this. So I'll give you a couple seconds to hit the pause button. Okay, so maybe you've worked on this, maybe you haven't, but I want to note that she gives you hints. This is awesome. All right, so not only does she give the solution, but she also gives hints. So for this problem, here are the 3 hints. Try a hash table. Could a bit vector be useful? Or can you solve it in order n log n time? Okay, what might a solution like that look like? And if you've taken algorithms, when you see order n log n, that really should make you think about certain kinds of algorithms, which is what she's trying to help you to do. Here's what the solution looks like. The first thing, you should first ask your interviewer if the string is an ASCII string or a Unicode string. That just cracked me up. I never thought about that. So that's just an example of how detailed and thoughtful these solutions are. It's really awesome. So she goes ahead. She gives an example where you have basically an array that where the index of each array, it's kind of like a hash table, perfect hash table, because each index represents one character, and so you can iterate through this string as long as there's only 128 characters in your character set, which is just basic ASCII. And then if you found the character already as you go through, you're good. So this is order n, and she talks about that, and then she talks about, well, you could use a bit vector, and then you could reduce the space usage by a factor of 8, which could be significant. Okay, I'm just going to quickly show you some other examples just to give you a vibe for the book. A stack that has a function min. Check if a binary tree is a binary search tree. There's binary representation questions. There's kind of an analytical question where you have a 5-quart jug, a 3-quart jug, unlimited supply of water. How would you come up with exactly 4 quarts? So there's no, there's no coding there, but it tests your ability to think. How would you design? This is a system design question. How would you design a chat server? In particular, provide details about the various backend components, classes, and methods. What would be the hardest problems to solve? Really great question. All right. You have 10 billion URLs. How do you detect the duplicate documents? In this case, assume duplicate means that the URLs are identical. Very good question. It's, so it's not something you can just make a hash table or a bit vector and solve. How would you test an ATM in a distributed banking system? Okay, great question, kind of a software engineering question. And then here's the last one is a threading question where you want to make sure that the first method is always called before the second and second is called before third. And again, for all these, she has hints before that you can look at before you actually look at the solutions. All right, so to conclude, what I want to say is this book is a beast. Okay, I weighed it. It was 3 pounds. It's 2 inches high. I carried it home one day, and I just thought, I don't want to carry this thing around. All right. The good news is that the problem part of the book occupies a very small section. Actually, it's even smaller than what I'm showing here. It's probably half that size because I was including the little introductory material. And the solutions, occupies, at least 2 inches out of the 3 inches. So here's what I recommend. Once you buy the book, just slice it up into pieces, and then you can just carry around the question section and the appropriate solution section at any one time, and you should be good. Finally, what do I recommend? Okay, obviously buy the book. And then because it's just got a wealth of knowledge. I know there are sites out there that you can do questions and answers, but really the book has a lot of more meta level knowledge in it that I recommend. It's just worth it to spend the $35 or whatever it is. And then I'd slice it up into little pieces that you can carry around with you. Buy a notebook and a pencil, and then do one problem a day for 6 months. Take you 20 minutes, 30 minutes, I don't know. And and then along with the other preparatory stuff you're doing, following the preparation map, you should be good to go. When do you start doing this? I recommend you start this while you're taking ICS 311, okay, or after. I mean, if you're just seeing this, you've already taken 311, start now. But if you're taking 311 now, start doing it. You don't have to wait till you're done with 311. I recommend you start doing it while you're doing 311. The reason for that is that it's pretty elementary algorithm knowledge. And then also, it's going to help you be motivated to really study the ICS 311 stuff and understand why it's so important to you. All right, so good luck. Hope you enjoyed this. Crack that coding interview, but more importantly, get competent with computer science. It's a great thing.